Hey everyone, welcome to review number 1. We're going to be reviewing what sine is and what it means and how we can compare values of sine. Hope you all are doing well and staying safe and healthy. Remember, your mental health is your first priority. This all comes second, but let's get started. So first of all, let's discuss what is sine. Remember, we talked about sine ratios, and that the sine of any angle, remember theta means angle, is equal to the opposite over its hypotenuse. And remember that when we looked at a right triangle, when we're given an angle, let's say this is theta, the opposite side is its opposite, and the hypotenuse is what's always opposite to the right angle. So what this means for sine is that it's the ratio between height, which we'll call that vertical height, and its hypotenuse. So when we work with a point moving in a circular path, we know that the hypotenuse is actually the radius. So we're going to revise that a little and say radius. So here we know that the height is actually less than its hypotenuse, so it's going to be less than 1 here. But because it's above this, what we call the midline, we know, here I'm just going to highlight the midline. Right here, that's the midline. We know that it's going to be positive. So I'm going to shade in what we know is positive. So we know that this green shading, everywhere that height and that sine value is going to be positive. So sine of theta is positive. So you can guess that now, if we look at whatever is below the midline, any point that's below the midline is going to tell us that our sine is negative. And this is where we can see where the greatest value of sine is. It's at the highest point of the circle. So the highest point of the circle I'm going to point out in black is here. And that means the ratio between the height and its hypotenuse is actually 1. So sine of 90 we know is 1 because the hypotenuse matches this height. There's no actually hypotenuse, we can call it the radius. Similarly, we know that the lowest point, which I'm going to mark in purple, is down here. And that's at angle 270 degrees. And since it's negative, we know that it's negative. We also know that the height is actually the radius, so it's a negative 1. Something to point out here, which I forgot to mention, and I want to mention it right now, is that remember, we always start at the positive or right-hand side of this little, I'm going to call it the x-axis, and then we're always going to move counterclockwise. Wow, that's a mess, but you know what I'm getting at. Okay. So now we're just going to order these values of sine from least to greatest. So my point of recommendation is really just to label where all of these heights are. Where is the height at 20 degrees of rotation? And I'm going to do this in this pretty orange color. So we know that about 20 degrees from here, from this starting location, this is about 20 degrees. We know... Whoops, I don't know why. And then I'm just going to keep labeling. So this is 163 degrees. 347 is closest to 360. here, I'm going to label my big four easy ones. So this is 90. We know that this is 180. This is 270. And this is 0/360. So 347 is actually, I'm going to say here. 273 degrees. It's a little past 270. And then sine of 189 is a little bit past 180. So now we're just going to look at what is higher on the circle. So I know a lot of people are going to try to go clockwise and go and try to do the heights from there, but you're actually looking from the lowest point to the highest point. Remember, the lowest point is at 270 degrees, and we know that the highest point is at 90 degrees. And I just realized I messed up a little. This is 273. Okay, so we look at what the lowest point on the circle is. We know that it's the one that's closest to 270. So that is we know that the value of sine at 273 degrees is going to be the least. Then we go up and we know that 347 is, the point at 347 degrees is actually lower than the one at 189 degrees. These are all negative, but this is, the one at 347 is more negative. So we're going to go 7 degrees. And then now we're going to still focus on the negatives because that's always going to be the lowest. And we know that it's going to be at sine of 189. And then this is a pretty hard one. So we're looking at the difference between the sine of 163 and the sine of 20. From these estimates that I drew, and they weren't great estimates, we look at it and we're like, oh, that looks the same. They must be the same height. However, you need to make sure we remember what the value of sine means. So think about the angle that is opposite here. In this case, whatever has a greater angle from the midline is going to be at the higher point. So we know that this is 20 degrees from the midline, right? And then what's 180 minus 163? 17 degrees? Yeah. This is 17 degrees from the midline. So which one is greater? The one that is 20 degrees from the midline. It's a higher angle, so it's a higher point. And so we know that the lower point is at, the lower value of sine is at sine of 163 degrees. Sorry, this is just really bad. I didn't plan out my space very well. Sine of 163 degrees. And then the greatest value of sine is actually at sine of 20 degrees. Which is crazy because it's a very small angle, but it's the greatest angle from the midline, which is pretty cool to see. So just make sure that, I know it's pretty bad here, but this is an arrow pointing to, this is, we're going from sine of 189 to sine of 163. Okay, last but not least, we're going to go into matching values of sine. So we know that the values of sine are equal if their heights are equal. So that's something to make sure we know. And keep in mind, we know that the heights are equal if the angle opposite to that height is the same. So these need to be the same. If you remember from geometry, this means that the angles are congruent. Okay, so let's first look at where 230 degrees is on the circle. So we know, again, I'm going to label this is 90, 180, 270, and 360. So we know that 230 is a little bit past 180, but a little bit before 270. So I'm going to label it here. This is 230 degrees. And we're looking at actually this height right here. This is going to be our value of sine. So we need to think about where it's equal. Okay, I know that we can find an opposite point here where the height is the same. But what is that degree of rotation here? So this is where we're going to have to do some sort of calculations. We know that it has to be the same amount away from here, from the midline. So we know that the degree of rotation from 180 degrees to 230 degrees is, I'm going to say 50. Yeah, 50 degrees. So we know that it has to be 50 degrees from here as well. So a little bit before 360, so we're going to have to take 360 and subtract it by 50 degrees. So this angle is actually 310 degrees. So we know that the sine of 230 is equal to the sine of 310. And then another way we could figure it out is it must have the same value of sine, or the same height, when we just go back around again. We make one full rotation again. So we're going to take, so what resembles a full rotation is an extra 360 degrees. So we take our 230 and we can add 360 degrees to it, which is going to be 590. So sine of 310 is equal to the sine of 590. Okay, pretty easy. And you could have also even done a 360 degrees from here. You could have done it from 310 and gotten 670, the sine of 670, sorry. Okay, so let's go now move on to sine of 15 degrees. So again, we're going to do the same thing. We're going to draw this point that's 15 degrees from the starting location. We know that its heights have to match in order for the values of sine to match. So I'm actually going to go to the opposite side here. You know that this point needs to be that point that has the same height. In order for them to have the same height, they need to have the same opposite angle. So we know that this is 15 degrees from the midline, so it must be 15 degrees from the midline. This is a little bit before 180, so we're going to take 180 and subtract it by 15 degrees. And we should get 165 is this point here. Yes. So the sine of 15 degrees is equal to the sine of 165. Again, we can do another full rotation. So we can take 360 and add it to the 15 degrees. So another value of sine that's the same is sine of 360 plus 15 is 375. Okay, so this is just a review on sine. Please take care of yourselves. We're all thinking of you. And hope you stay safe and healthy, and hopefully we get to see you when this whole thing ends.